So, um, imagine you are the CEO of a Fortune 500 company,
Okay, I can picture that.
right? And you are standing in front of this packed room of shareholders. You've got this massive, beautiful chart projected on the wall behind you.
High stakes.
Exactly. And you confidently announce that your Q3 revenue in the Asia-Pacific region has doubled. The crowd murmurs in excitement. The stock price immediately ticks upward.
Sounds like a great day at the office.
Well, it is, right until a terrified vice president of finance rushes the stage and whispers in your ear that the numbers are completely wrong.
Oh, no.
Yeah, the revenue didn't double. It actually shrank by 4%.
That is a
A
disaster.
total disaster.
Yeah.
Your newly integrated, state-of-the-art artificial intelligence system didn't actually know the answer to your query, so it simply made one up.
It hallucinated.
Exactly. It hallucinated. The stock tanks, people get fired, and suddenly you are facing a massive SEC investigation.
Yeah, that is literally the absolute nightmare scenario keeping enterprise executives awake at night right now.
Because, you've seen the headlines, right? We all see the AI writing beautiful poetry or generating those photorealistic images of astronauts on Mars.
Right, consumer AI, which is fun.
It's super fun. But when you scale that technology up to run a multinational corporation, the stakes change entirely.
They absolutely do.
So the question for you listening is, how does a global enterprise actually trust an AI to run its financial modeling or manage its global supply chain without the whole thing just going completely off the rails?
It's a huge question because that nightmare scenario you just painted, it highlights the fundamental divide between consumer-grade AI and enterprise-grade AI.
Right.
Like an AI generating a slightly weird image of a horse with 6 legs. That's amusing.
We laugh and post it online.
Exactly. But an AI hallucinating the Q3 revenue projections for a publicly traded company? That is catastrophic. The risk profile shifts from a minor annoyance to existential corporate destruction.
Yeah, you just cannot afford a single hallucination when you're dealing with compliance or payroll or live supply chains.
Zero margin for error.
So bridging that gap between the wild, creative potential of AI and the strict, secure reality of enterprise business, that is exactly what we're getting into today on this deep dive.
And we have some incredible source material to work from today.
We really do.
Yeah.
We are looking at a highly detailed architectural blueprint for generative AI in the enterprise.
Yeah, specifically, these sources map out how human intent is bridged with technical execution using the combined power of SAP and Amazon Bedrock.
It's honestly a phenomenal stack of material.
It really is. I mean, we are essentially looking at the schematics for a modern enterprise brain.
Yeah, it shows how you take the raw, almost chaotic reasoning power of a large language model and put it into this highly regulated, secure straitjacket, basically, so it can actually do meaningful work.
Straitjacket is a good way to put it, yeah.
So our mission today is to cut right through the buzzwords. We want to take a look under the hood.
Let's get into the wiring.
Exactly. We're going to deconstruct this blueprint so you can understand exactly how enterprise-grade AI actually works securely, how it scales across thousands of employees without causing massive data leaks, and ultimately what it means for the future of business.
It's the ultimate how it works guide.
But, before we look at the wiring and the code, I kind of want to understand the motivation.
The why behind all this.
Right, because replacing complex drop-down menus with a chat interface sounds nice, but it doesn't really justify a multi-million-dollar, multi-year IT overhaul, does it?
No, definitely not.
So why are these massive enterprises investing so much capital into this specific architecture?
Well, the motivation goes far beyond just building a better user interface. The source material outlines what they call the 4 dimensions of value.
Okay, 4 dimensions.
Yeah, and this framework really dictates the entire architectural strategy. So the first dimension is new experiences.
Which is the chat interface stuff.
Right. Now, you mentioned drop-down menus, but think about the reality of legacy enterprise software. It is notoriously hostile to the user.
Oh, I know. I have lived that nightmare.
Right. An employee might have to click through 14 different nested menus, memorize specific obscure transaction codes, and navigate multiple disconnected screens just to file a basic expense report.
Or initiate a purchase order. It
Yeah.
feels like you need a degree in computer science just to buy office supplies sometime.
Exactly. And that friction costs corporations millions of hours in lost productivity.
Is it clicking around?
Just clicking. So the new experiences dimension is about stripping away that friction by introducing conversational interfaces. You just use natural human language to tell the system what you want to do.
Which is great, but that only works if the system actually understands the context of your business, right?
Right. Precisely. Which leads to the second dimension. Insights.
Okay, insights.
This isn't just about gathering data into a static dashboard. It's about instantly extracting hidden patterns, trends, and correlations from massive SAP datasets.
I have to push back a little on that, though.
Go for it.
Because, we've had data analytics teams and business intelligence software for over a decade. Extracting patterns isn't exactly a new concept.
Fair point.
So how does this AI architecture do it differently than, say, a team of data scientists running SQL queries?
The difference is the velocity and the democratization of that data.
Democratization, meaning who gets to use it?
Right. A human analytics team might take 2 weeks to compile a report, clean the data, identify the variables, and build the visualization.
By the time that report hits a manager's desk, the market conditions have probably already changed.
Exactly. But generative AI allows a manager with zero technical background to ask a complex analytical question and receive a synthesized, accurate answer in about 3 seconds.
Wow, okay, 3 seconds versus 2 weeks. That's a shift.
And that brings us to the third dimension, which is productivity.
Which is the automation piece.
Yeah, the automation of those repetitive operational tasks. It's about freeing up human capital from routine data processing so they can actually focus on high-value strategic execution.
So, let me get this straight. If the system can understand my natural language request, pull the insights instantly, and automate the execution, what is left for the human to actually do?
That is where the fourth dimension comes in, creativity.
Creativity. Okay.
This is where we break beyond mere automation. It's using generative AI to assist in product ideation, asset generation, and complex problem solving.
So using the AI as a collaborative partner, essentially.
Exactly. You are not just asking it to do math, you are asking it to propose solutions based on parameters you set.
Okay, I want to use an analogy here, because
Yeah.
looking at these 4 dimensions, experiences, insights, productivity, creativity, it feels like a really massive leap in capability.
It is a huge leap.
It's kind of like the difference between buying a single smart bulb for your bedroom.
Yeah.
You clap your hands to turn it on,
Yeah.
which is neat, but ultimately just a parlor trick, versus wiring a 50-story skyscraper for a centralized predictive climate control system.
I like that.
Right. The skyscraper system doesn't just respond to a switch. It adjusts the temperature based on how many people are in a room, what the weather's doing outside, and historical usage patterns, all while optimizing energy costs.
That analogy hits the nail on the head.
Yeah.
Definitely. The smart bulb is the standalone chatbot that people play with on their phones. The 50-story skyscraper is this SAP and Amazon Bedrock blueprint.
And building a skyscraper like that has to have a pretty serious ROI.
It does. And this blueprint points to a very specific strategic endgame. The sources highlight a sample enterprise that integrated these AWS machine learning solutions into their SAP setups and achieved over $500,000 in tangible operational savings rapidly.
Wait, $500,000?
Yes.
Just by implementing this integration that fast.
And that is merely the low-hanging fruit. Seriously.
Yeah, that's just the easily quantifiable savings from reducing manual labor and streamlining basic processes. The source notes they simultaneously enhanced vendor delight.
Vendor delight, which is a softer metric, but incredibly valuable for supply chain stability, I'd imagine.
Hugely valuable. But the real end game, the concept that I find most compelling in this whole blueprint, is what they call predictive supremacy.
Predictive supremacy. I mean, that sounds like a sci-fi movie title.
It does, a little bit.
Let me play the skeptic here for a second. Is this just corporate marketing speak for cutting costs and replacing humans in the name of productivity? Or is there a tangible mechanism behind this supremacy concept?
It goes much deeper than cost cutting. Predictive supremacy represents a fundamental business transformation.
Okay. How so?
Well, traditionally, businesses operate by looking in the rearview mirror.
Right. You look at last quarter's numbers to guess what you should do next quarter.
Exactly. Predictive supremacy is about moving beyond reporting the past and actively forecasting the future based on real-time variables. Explain how that actually works in practice, though. How do you move from looking at a historical ledger to forecasting the future?
The blueprint describes generative AI enabling natural language inquiries into quarterly revenue products and instantly delivering comprehensive, real-time visualizations.
Right.
But let's look at the mechanism behind that. When a CEO asks, how will a 5% increase in raw material costs affect our Q3 margins in Europe, the LLM isn't just drawing a picture based on a guess.
Right, because how does it build a chart on the fly? The LLM isn't like opening Excel and typing in numbers.
No, and the mechanism is fascinating. The large language model receives the natural language question. It translates that human intent into a complex database query.
So it's generating code.
Yes, perhaps generating Python or SQL code in the background, it sends that query securely into the SAP Agano database, which holds all the live enterprise data.
Okay.
The database returns the raw numerical output. The AI then takes those raw numbers, analyzes the variance, and wraps that data into a user interface framework.
Like SAP UI5 or something.
Exactly like SAP UI5. It uses that to render a visual chart on the user's screen. And it does all of this in a matter of seconds.
Wow, it just changes the entire velocity of the business.
Completely.
You aren't driving while looking in the rearview mirror anymore. You are basically looking at a GPS that is actively predicting traffic patterns 3 towns over and then automatically rerouting you.
That shift in velocity turns generative AI from a short-term productivity tool into a long-term investment engine for complex market analysis.
Okay, that paints a really clear picture of the strategic endgame from the boardroom perspective.
Yeah.
But I want to pivot because the source material doesn't just stay up in the clouds of executive strategy.
No, it gets very practical.
Yeah, it brings the architecture down to the actual human beings on the ground.
Yeah.
So how does this blueprint transform the daily granular lives of enterprise workers?
Well, the architecture is ultimately only as good as its utility to the end user, right?
Right. If the employees can't use it, the blueprint fails.
Precisely. The source provides 3 distinct persona deep dives to illustrate how this technology solves very specific, real-world problems.
Okay, let's go through them.
The first persona is a finance manager.
So what does their day-to-day look like before this AI integration?
Their primary bottleneck is static reporting. They are entirely dependent on IT or dedicated data teams to build reports.
Which takes forever.
Exactly. When an executive asks them for an analysis, they have incredibly long lead times. They spend 90% of their time gathering and formatting data and only maybe 10% of their time actually analyzing it.
So they are basically functioning as data janitors rather than financial strategists?
You've got it. Data janitors. So the generative AI solution for this finance manager is dynamic natural language prompting.
So they can just ask for what they want.
Yes. They can sit at their desk, bypass the IT ticket queue entirely, and generate near real-time insights directly from their SAP data. They can ask the system to model different financial scenarios on the fly.
The business impact there is obvious. Accelerated executive decision-making. Rapid preparation for strategic meetings. It just elevates their entire role.
Absolutely.
Now, the second persona is where it gets really interesting for me because it is way less glamorous than financial modeling.
Oh, for sure.
The second persona is an accounts payable manager. And when I think of accounts payable, I just think of massive stacks of invoices, slow approvals, and people chasing down signatures.
Unfortunately, that is the reality for most enterprises. The bottleneck identified in the blueprint for this persona is disjointed manual review processes.
Just paper pushing.
Right. And this causes severely delayed payments, which in turn causes supplier friction.
And supplier friction is bad news.
It's terrible. If you consistently pay your vendors late because your internal routing is slow, those vendors will stop prioritizing your orders. They might hold shipments, which then cascades into a massive supply chain crisis for your company.
Okay, I understand how AI can help a developer write code, or how it can help a finance manager analyze numbers. But an accounts payable manager.
It's a huge use case.
But how does AI actually solve supplier friction? I mean, it's not writing polite apology emails to the vendor, is it?
No, it addresses the root cause of the delay.
Yeah.
The generative AI solution here is automated invoice matching and workflow generation.
Okay, break that down.
Consider what a human has to do to approve a complex invoice today. They have to perform a 3-way match.
A 3-way match.
Yeah. They look at the purchase order to see what was originally requested. They look at the receiving receipt to see what actually arrived at the warehouse. And then they look at the invoice from the vendor to see what they're actually being charged for.
And I'm guessing if those 3 documents don't match perfectly, everything just grinds to a halt.
Precisely the problem. And these documents are often unstructured. They come in different formats, different languages, with completely different line item descriptions. A human has to manually decipher all of that.
Which sounds tedious.
It is.
Well-
But generative AI, utilizing optical character recognition alongside deep semantic understanding, can actually read those unstructured documents.
It understands the meaning.
Exactly. It understands that item 4A on the invoice is the exact same thing as Mocha Chip Alpha on the purchase order. It performs the three-way match instantly.
Wow.
If there is a minor acceptable variance, it just approves it. If there is a major discrepancy, it flags it for a human, along with a nice summary of exactly what is wrong.
So it understands the actual context of the documents, not just keyword matching. The time saved there must be totally staggering.
It is. It leads to prompt payments, it eliminates those operational blockages, and it guarantees what the blueprint calls vendor delight.
Because you're the one customer who actually pays on time.
Exactly. You become a priority client for your suppliers simply because you pay them faster and with less hassle than anyone else.
That is amazing.
Yeah.
Okay, that brings us to the third persona, which bridges into the highly technical side of the enterprise, the SAP developer. These are the people actually building and maintaining the internal systems.
Right. And their bottleneck is a very specific, widespread industry nightmare.
Which is,
A total lack of documentation for custom legacy ABAP programs.
oof. Okay, let's unpack that for a moment. ABAP is the programming language created by SAP for developing business applications.
Yes.
And legacy code means it's been running the company for a very long time, sometimes decades.
That's the terrifying part. Many massive enterprises run on ABAP code that was written in the late 1990s or early 2000s.
Oh, wow. Y2K era stuff.
Exactly. And the original developers who wrote that code are often long gone. They've moved to other companies or they've retired.
Right.
So a new developer is hired, they're tasked with updating a core system, and they open up a file with tens of thousands of lines of highly customized code with absolutely no notes or documentation explaining what any of it does or how it connects to other systems.
That sounds absolutely terrifying. It's like trying to defuse a bomb where all the wires are the exact same color and the instruction manual is written in a dead language.
That is a very accurate description.
And if you cut the wrong wire, you take down the company's entire payroll system. So how does AI solve this bomb defusal problem?
The solution involves utilizing natural language prompts to generate instant code snippets and documentation via the AWS SAP ABAP Assistant.
Okay.
The new developer can highlight a massive block of mysterious legacy code and simply ask the AI, explain step by step what this function does and what database tables it modifies.
Just plain English.
Plain English. The AI, which is trained on vast amounts of programming logic, analyzes the code's behavior and generates comprehensive plain English documentation.
It basically reverse engineers the intent of the original programmer.
It does. And the business impact highlighted in the source is the accelerated delivery of new features and significantly reduced project risk.
Because they aren't guessing anymore.
Right. If the developer actually understands the legacy architecture, they are far less likely to inadvertently break the system when they introduce an update.
Okay, so looking at these three personas, the finance manager doing strategic modeling, the accounts payable manager automating invoice matching, and the SAP developer reverse engineering legacy code, they are operating in completely different universes. Right?
Very different, yes.
But there is a unifying thread here, isn't there?
Yes. The unifying thread is the complete elimination of operational friction.
Friction.
Whether it's the friction of waiting weeks for a data team, the friction of manually verifying unstructured invoices line by line, or the friction of deciphering undocumented software. By automating the mundane, the enterprise frees up its human capital for high-value execution.
You aren't replacing the human worker.
Not at all. You're
Right.
elevating them from a processor of data to a strategic decision maker.
But that raises a massive logistical question for me.
Okay, what's that?
You have these empowered personas all over the company. The finance manager needs real-time data from the supply chain. The developer is building new tools for human resources.
Right.
If everyone is just buying their own standalone AI tools and running them on their own laptops, you don't have a cohesive enterprise. You just have total anarchy.
Yes, you would.
So they need a central nervous system to coordinate their efforts across the entire company, right?
Absolutely. And that observation leads us directly to the enterprise-wide capability map outlined in the blueprint.
The capability map.
This map illustrates how all these disparate pieces fit together without collapsing into chaos. At the very center of this map, the core hub is SAP Business AI, specifically a tool called the Joule Copilot.
Joule. Joule. So Joule isn't just a separate app sitting on someone's desktop. It operates more like a master translator standing in the middle of a massive global marketplace, routing everyone's requests to the right places.
That is the perfect way to visualize it. Joule is the central node, the singular entry point, and the blueprint maps out how this central node connects to 6 distinct key areas of the enterprise.
Okay, what are the 6 areas?
Well, we've already touched on the first one, ERP and finance, where Joule facilitates dashboard authoring and predictive planning intervals.
Right, the finance manager. Let's move around the map. What is the second area Joule connects to?
The second area is labeled industries. This focuses on tailored compliance, operations, and commerce optimizations that are highly specific to whatever field the enterprise operates in.
Okay, give me an example of how that specificity works.
Sure, a pharmaceutical company has vastly different regulatory compliance needs than an automotive manufacturer.
Obviously.
So when a user asks Joule a question about a product launch, the AI must instantly understand that it is bound by FDA regulations, not just general business logic. The system adapts to the specific rules of the game you are playing.
That makes total sense.
Okay.
What is the third area connected to the hub?
IT and platforms. We discussed the developer persona earlier. This area involves natural language generation of workflows using SAP Build Process Automation and creating integration flows via the SAP Integration Suite.
Wait, what does that actually mean in practice? What is SAP Build Process Automation actually doing?
Imagine an IT worker needs to create a workflow for onboarding a new employee. Instead of writing custom code to connect the HR database to the email server and then to the IT hardware provisioning system.
Which would take days.
Exactly. Instead, they simply tell Joule, create an onboarding workflow that triggers when a contract is signed, orders a laptop, and sends a welcome packet. The AI uses SAP Build to generate that complex integration flow automatically.
Wow. Okay, so IT is building the tools way faster. But what about the people actually doing the work? Managing human capital is notoriously messy.
Very messy.
How does this map apply to human resources, which I'm guessing is the fourth area?
It is. HR represents a massive opportunity for AI integration. The blueprint highlights AI-assisted talent acquisition and skills management.
Okay.
Think about the challenge of managing a global workforce of 50,000 people. An HR system integrated with Joule can continuously analyze the evolving skill gaps within the company's current projects.
And then what?
It can instantly match those gaps against the internal talent profiles of existing employees or against incoming resumes from external candidates.
Oh, wow. So it moves HR from simply managing personnel files in a cabinet to actively optimizing the workforce based on predictive project needs.
Exactly.
If the company knows it's launching a major AI initiative in 6 months, the system can identify which current employees have the adjacent skills to be retrained rather than just blindly hiring new people.
You're hitting on the core concept. It's incredibly proactive. The fifth area on the map is sourcing and procurement.
Which relates to the accounts payable manager paying the bills.
Right, but at a broader strategic level, this area uses AI for intelligent supplier recommendations and automated contract generation.
Wait, generating the legal contracts themselves?
Yes.
That removes an incredible amount of legal bottlenecking.
It does. And the final sixth area on the map is supply chain. This involves utilizing AI forecasting capabilities and visualizing material group performance.
Let's put that into a real-world scenario. What does AI forecasting look like during a supply chain crisis?
Okay, let's say a major shipping canal is blocked by a grounded cargo ship.
Like the Suez Canal a few years ago.
Exactly like that. In a legacy system, it might take days for a company to manually audit their manifests to even realize their vital components are on that specific ship.
By which time it's too late.
Right. But with Joule integrated into the supply chain, the system can instantly identify the delayed container, map those specific components to a factory floor in Germany, calculate the exact production delay,
Wow.
and automatically source alternative compatible parts from a supplier in Mexico to keep the factory running.
That is insane. When you lay out the map like that, ERP, industries, IT, HR, sourcing, supply chain, it is just staggering in its scope.
It covers everything.
But I have a fundamental question about the architecture here.
Yeah.
Why is it so crucial to have Joule sitting right in the middle of all this?
What do you mean?
Well, if the HR department has a budget for an AI tool and the finance department have their own budget, why wouldn't they just buy separate specialized AI software tailored for their specific needs? Why force everyone through Joule?
Because that is the exact trap that crippled enterprise agility over the last 20 years. If HR buys a standalone AI system and finance buys a completely different one, those systems cannot communicate. The data is completely siloed.
Ah, right.
Having a single co-pilot for the entire enterprise map prevents those data silos. Joule provides one unified entry point. It creates a cohesive user experience and ensures that insights can cross departmental boundaries effortlessly.
Okay, give me an example of crossing boundaries.
When the CEO asks a question, Joule can pull the financial data, correlate it with the supply chain disruption, and check the HR database for the engineers needed to fix the problem, all in one cohesive response. You can't do that with siloed tools.
I see the power of breaking down those silos. But frankly, it also introduces a terrifying thought for me.
Which is?
You have all these different departments, HR, IT, finance, supply chain, throwing their disparate business intent
Yeah.
at the system all at once. The HR manager is asking about salaries, the developer is asking for code, the supply chain manager is asking about shipping routes.
Yeah, that's a lot of traffic.
How do you keep the whole thing from turning into a chaotic, unmanageable mess? If everyone is touching the exact same central system, how does it not just break down under the sheer complexity of it all?
Well, the architects of this blueprint anticipated that exact vulnerability. It brings us to what I consider the golden rule of this entire integration strategy, the clean core convergence.
The clean core. It sounds very, I don't know, sanitary. But what does it actually mean in terms of software architecture?
To understand the clean core, we really have to look at the mistakes of the past.
Okay.
Historically, enterprise software became an absolute nightmare to maintain because companies would buy a standard SAP system and then heavily customize the core code to fit every little unique departmental need.
Just tacking things on.
Tacking things on everywhere. They bolted on so many cuts and modifications that the system became this fragile web of spaghetti code.
So when it was time to upgrade the software to a new version,
Everything would break. Because the core was so messy, every upgrade was essentially a multi-million-dollar crisis.
oh man, so how does clean core fix that?
The clean core philosophy dictates that you keep the foundational ERP system completely standard, secure, and unmodified. You do not touch the core.
Okay.
The blueprint provides a diagram for how this applies to generative AI. On the left side, you have all that disparate business intent, the diverse requests from all the different personas. The diagram shows all these requests funneling into a central hexagon labeled the clean core pattern.
Okay, so every single AI request has to pass through this central checkpoint.
It is an absolute requirement. The foundational rule stated in the sources, enterprise AI is not a collection of siloed tools.
Right.
Whether you are delivering dynamic financial insights, generating ABAP code, or automating supply chain workflows, all generative outcomes rely on this singular unified pattern.
This brings me back to my nightmare scenario of the CEO hallucinating data or leaking secrets.
The SEC investigation.
Exactly. What does this clean core checkpoint actually mean for the security of the company's data? If I'm asking an AI about unreleased product designs or sensitive employee salaries, how does this pattern protect those crown jewels while still connecting to outside third-party AI brains?
That is the most critical function of the pattern. Moving out of that central hexagon, the pattern connects to the singular unified architecture. The source explicitly states that this pattern bridges the SAP application layer directly to world-class LLM's large language models while maintaining a secure SAP-recommended clean core approach.
Take that a step further for me. It bridges the private SAP application layer to the external LLMs. What does that mean mechanically?
It means that you harness the immense reasoning power of massive external AI models like those hosted on Amazon Bedrock, but you absolutely do not allow those models to rummage around in your private databases unsupervised.
So they don't get free rein.
Not at all. The clean core pattern is essentially an incredibly strict border control. It dictates how data is formatted, how requests are authorized, how personal identifiable information is stripped or masked before the prompt ever leaves the enterprise boundary, and how the response is verified when it comes back.
Let me make sure I'm grasping this. It's like having a customs checkpoint at the border of your company's digital territory.
Exactly like customs.
You can trade with the outside world. You can send a request to Amazon's AI engines, but nothing crosses that border without being thoroughly inspected.
Yes.
So if an HR manager asks the AI to summarize an employee's performance review, the clean core checkpoint steps in, redacts the employee's name and social security number, sends the sanitized text to the external LLM to be summarized, gets the summary back, and then securely reattaches the employee's identity on the internal side before showing it to the manager.
That is an excellent, excellent breakdown of the mechanism. The external LLM never sees the sensitive data, but the internal user still gets the full benefit of the AI's reasoning power.
That is incredibly clean.
It guarantees that every single interaction follows the exact same stringent security protocols, keeping the core system clean and safe.
Okay, we've talked about the architecture conceptually. We understand the strategy, the personas, the capability map, and the vital necessity of this clean core concept.
The why and the what.
Exactly.
Yeah.
Now, I want to lift the hood. I want an exploded view of the engine itself. How is this actually built from the ground up?
All right, let's get into the wiring. The blueprint breaks the architectural engine down into 3 distinct, highly specialized layers.
3 layers.
Yes, understanding how these layers interact is key to understanding how a simple human question turns into complex technical execution.
All right, let's start at the top where the user interacts. Layer 1.
Layer 1 is the application layer, specifically driven by SAP Build. This is the user interface and the business logic that sits right behind it.
Okay.
It utilizes the Cloud Application Programming Model, often called the SAP model, along with SAP UI5 to deliver the end-user experience.
You just threw a lot of acronyms at me. What is the CAP model and what is UI5?
Sorry, let's break that down. The CAP model is a framework of languages, libraries, and tools provided by SAP for building enterprise-grade services and applications. It standardizes how apps are built so they all communicate efficiently.
And UI5?
SAP UI5 is the front-end development toolkit. It's what actually draws the buttons, the charts, and the text boxes on the user's screen in a clean, consistent way.
Okay, let's ground this with an analogy. If this entire architecture is a high-end restaurant, layer 1, this application layer, is the dining room. The dining room, I like it. It's the menus, the tables, the ambiance, and the waiters. It's where the customer sits and interacts. It needs to look good, be intuitive, and provide a seamless experience.
That analogy works beautifully. The finance manager or the supply chain director interact exclusively with layer 1. They don't see the massive infrastructure humming beneath them.
Okay, so what's beneath the dining room?
Underneath that dining room is layer 2, the orchestration layer.
The orchestration layer. This sounds like the command center where the actual routing happens.
It is the absolute critical middleman. In this blueprint, layer 2 is the generative AI hub, centered around the SAP AI core.
The hub.
The source describes this as the central hub that manages AI APIs, trust, control, and prompt engineering, all without exposing the underlying transactional systems.
So return to our restaurant analogy. If layer 1 is the dining room, layer 2 is the expediter standing in the middle of the kitchen.
Yes, the expediter.
The expediter takes the ticket from the waiter, verifies that the order makes sense, routes it to the specific chef who handles that dish, checks the food for quality control when it's done, and ensures the whole chaotic kitchen runs efficiently.
You've got it. The orchestration layer handles authorization and trust management. It verifies the user's credentials. It manages rate limiting so the system isn't overwhelmed.
So no one spam clicks the system to death.
Exactly. It handles the partner build components and the business application studio. It is the traffic cop and the security guard all rolled into one.
I have to push back here, though, because this seems overly complicated.
How so?
If I have an app on my phone, it usually talks directly to a server. If I have a question for the AI, why can't my SAP build app in layer 1 just send a request directly to the AI models in layer 3? Why do we need an entire orchestration layer sitting in the middle, adding latency and cost to the process?
Because direct connection is the enemy of the clean core. If you plug the application directly into the foundation model, you bypass all enterprise controls. You introduce chaos.
The Wild West.
Exactly. The orchestration layer is vital for prompt engineering and context management. An employee might type a vague 3-word prompt. The orchestration layer takes those 3 words, injects the necessary system context, applies the security filters we discussed, and structures the prompt so the LLM understands exactly what is required.
Ah, I see.
Without layer 2, you have unsecured data flying out the door and useless hallucinated garbage coming back in.
It's the necessary friction to ensure safety. Okay, so layer 1 is the dining room. Layer 2 is the expediter. What is layer 3?
Layer 3 is the foundation layer. In this blueprint, it is hosted on Amazon Bedrock. This is where you access the massive, industry-leading large language models via secure APIs.
This is the kitchen itself, filled with the master chefs who actually cook up the intelligence.
Yes, the heavy lifters. And the blueprint specifically details the models available in this layer. From Amazon, you have the Titan family of models: Titan TextLite, Titan Text Express, and Titan Text Embeddings.
Why do they need 3 different versions of Titan? What's the difference?
Think of them as different tools designed for different workloads based on cost and latency. Titan TextLite is a smaller, faster model.
Like a line cook.
Right. It is highly cost-effective and perfect for simple tasks like basic text summarization or classifying an email. Titan Text Express is larger and designed for more open-ended text generation and conversational chat.
And the third one.
Titan Text Embeddings, which we will dissect in depth in a moment, is a highly specialized model crucial for how the AI mathematically understands enterprise data.
Okay, so that's Amazon Titan. And what other models are available in this Layer 3 kitchen?
The blueprint also heavily features Anthropic's Claude 3 models, which are accessible through Amazon Bedrock, specifically Sonnet, Opus, and Haiku.
Let me challenge this setup for a second.
Sure.
If Claude 3 Opus is widely considered one of the smartest, most capable reasoning models available, why would a company bother paying for Amazon Titan or the smaller Claude models? Why not just use the smartest AI for every single task?
It comes down to basic economics and latency. Using Claude Opus is like hiring a world-renowned theoretical physicist.
Okay.
If you need someone to solve a complex string theory equation, you hire the physicist. But if you just need someone to sort your mail into alphabetical order, hiring the physicist is a massive waste of money and time.
That makes perfect sense.
Opus is expensive and slightly slower because of its massive parameter count. If an enterprise processes 10 million automated customer service emails a day, using Opus for simple sentiment analysis would literally bankrupt them.
Right, the API costs would be astronomical.
Oh, so they use the smaller, cheaper, faster models like Haiku or Titan TextLite for the high-volume, repetitive tasks, and reserve the massive reasoning power of Opus for complex financial modeling or deep code analysis.
So Amazon Bedrock basically provides an entire shelf of different AI brains, and the orchestration layer intelligently decides which brain is the most cost-effective and efficient for the specific task at hand.
That is the elegance of the architecture. Customers can utilize these pre-trained models via a secure API, ensuring none of their data is used to train the base models. But this brings us to perhaps the most critical, complex, technical challenge of this entire blueprint.
Let me guess the problem. We have these brilliant foundation models in Layer 3, these incredible master chefs.
Right.
But out of the box, Claude 3 or Amazon Titan has absolutely no idea what my company's Q3 revenue was in the Asia-Pacific region. They have never seen my private supply chain manifest.
They haven't.
They are incredibly smart in a general sense, but they are entirely ignorant of my specific business.
That is the exact vulnerability. And as we established with the CEO nightmare scenario at the top of the show, if you ask a large language model a specific question about your business and it doesn't know the answer, it is not programmed to simply say, I don't know.
It's programmed to sound confident.
It is designed to predict the next most likely sequence of words. It will fabricate a highly convincing, completely false answer.
It will hallucinate.
Yeah.
So how does this three-layer architecture actually solve the hallucination problem? If the model doesn't know the data, and we can't afford the millions of dollars it would take to constantly retrain the core model on our daily data, what is the workaround?
The workaround is a process that has become the gold standard for enterprise AI. It is called grounding the AI retrieval augmented generation, commonly known as RAG.
RAG, R-A-G.
Yes, the source material outlines this workflow in significant detail. The core engine that powers this RAG workflow in this specific blueprint is the SAP HANA Cloud Vector Engine. Its primary function is to store all of your enterprise data as embeddings.
I have to stop you right there.
What?
I hear the word embeddings thrown around constantly every discussion about AI, but it is rarely explained clearly what actually is an embedding. I want to understand the math behind it.
Okay, let's break it down. Artificial intelligence models do not understand English words or German words or any human language.
Right.
They do not have a biological brain. They only understand mathematics. So, to make the AI understand a document, say, a complex HR policy manual, you have to translate the semantic meaning of that document into math.
Okay, how do you do that?
You run the text through a specialized embedding model, like the Amazon Titan Text Embeddings model we mentioned in Layer 3.
So what does that model actually do to the words?
It converts the text into a long string of numbers, a high-dimensional vector. These numbers represent the semantic meaning of the text, mapping concepts into a massive mathematical space.
A mathematical space.
Imagine a simple 3D graph you used in high school geometry with an X, Y, and Z axis. Now imagine a graph with thousands of axes.
A 1,000-dimensional space. That's really hard to picture.
It is for a human, but the math is straightforward for a computer. The model plots words and concepts as coordinates in that space. The magic is that words or sentences that mean similar things end up with coordinates that are mathematically very close to each other.
Give me a concrete example of how that mathematical mapping actually works.
The classic example used by data scientists is the relationship between royalty and gender.
Okay.
If you take the mathematical vector for the word king, subtract the vector for the word man, and add the vector for the word woman, the resulting coordinate in that thousand-dimensional space lands almost exactly on the vector for the word queen.
That is absolutely wild.
Isn't it?
So it is genuinely capturing the concept, the definition, and the relationships, not just looking at the letters.
It maps the fundamental meaning. So it's not just a keyword search. If I search a traditional database for the exact word dogs, it will only find documents with the word dogs. But if I search a vector engine, it knows mathematically that the vectors for puppies, canines, and golden retrievers are located right next door in that vast number space, even if the exact word dog is never used in the document.
Wow. So all of the enterprise's private, highly secure data, the financial ledgers, the HR documents, the supply chain logs, all of it is constantly being converted and stored in this SAP Agent Vector engine as these massive mathematical embeddings.
Yes. And that engine is what makes retrieval augmented generation possible. The blueprint outlines a specific four-step solution for how this flows when a user actually asks a question.
Let's trace the flow. Step 1 is the user query.
Right. A user provides a prompt. Let's say a logistics manager asks Jewel, what is our current inventory of alpha-grade microchips in the Berlin warehouse, and are there any delayed shipments?
And out of the box, Claude Opus has no idea. So what does the orchestration layer do?
Instead of sending that question directly to Claude, the system first takes the user's prompt, turns it into an embedding vector, and sends it to the SAP Agent Cloud Vector Engine.
Okay, the math version of the question.
Exactly. The engine then performs a similarity search, usually calculating the cosine distance between the vectors. It mathematically searches the millions of enterprise documents for the coordinates that are closest to the coordinates of the question.
It's mathematically searching for the answer based on meaning.
Exactly. It instantly retrieves the highly relevant private enterprise data, perhaps a specific inventory log from Berlin updated 10 minutes ago, and a shipping manifest from a supplier.
So instead of trying to teach the massive LLM everything about the company beforehand, we just use this incredibly fast vector math to go fetch the exact file folders it needs right before it answers.
That is the retrieval part of RAG. That retrieved enterprise data. Those specific file folders are then bundled together with the user's original question. This entire package is then fed to the Amazon Bedrock LLM.
So now the LMM isn't being asked to guess. It is basically being given an open book test.
That is the perfect way to describe it. The LLM reads the specific context you just handed it, applies its immense reasoning and natural language generation capabilities, and synthesizes an accurate, customized, and completely grounded response.
That's brilliant.
And the system explicitly forces the AI to base its answer only on the retrieved data. If the answer isn't in the retrieved documents, the prompt engineering in the orchestration layer instructs the AI to say, I cannot find the answer in the provided company data.
Which completely eliminates the hallucination risk.
Yes.
It's like bringing an incredibly intelligent consultant into your office. If you just sit them in a chair and ask them a specific question about your accounts, they can't answer. But if you hand them the exact ledger from last week and say, summarize this data and tell me the variance, they do it perfectly.
Exactly.
The RAG architecture powered by that vector math is essentially the system fetching that ledger instantly.
It elegantly marries the reasoning power of the foundation model with the strict factual accuracy of your private enterprise data.
Man, we've seen the engine, we understand the 3 layers, the clean core, and how RAG keeps it grounded in reality. I want to put this entire blueprint into motion now.
Let's do it.
The source material has a section dedicated to redefining customer satisfaction. Let's look at a high-stakes scenario where this entire complex architecture fires in real time.
This scenario is where the abstract architecture really proves its worth. Tracing this loop shows how fast, seamless, and powerful this technology is when deployed correctly.
Right.
The source outlines a loop for redefining customer service, which has historically been a massive pain point for both enterprises and consumers.
Oh, we all hate calling customer service. Walk me through the scenario. A customer has a problem.
The customer engages a chat interface on the company's website or app. In this specific AWS architecture, they are utilizing Amazon Lex to handle the initial natural language processing.
Okay.
The customer types a complex, frustrated message. I was overcharged on my last shipment of steel beams, and the tracking number you gave me for the replacement order doesn't work.
In a legacy system, that would trigger a chatbot to give a useless generic response, infuriate the customer, and eventually dump them into a 40-minute hold queue for a human agent.
Right, the classic bad experience.
So how does this architecture handle it?
The orchestration layer takes over. AWS Lambda and LangChain step in to process the intent of the message.
Let me pause you on LangChain, because that is another term that pops up constantly in AI spaces. What exactly is LangChain doing in this middle layer? Is it just chaining prompts together?
It is doing much more than that. Large language models are inherently stateless.
What does stateless mean?
They don't remember the last thing you said to them unless you feed the entire conversation history back to them every single time. Furthermore, complex tasks often require multiple steps. LangChain essentially acts as a sophisticated task manager and a short-term memory buffer.
Okay.
It allows the system to chain together a sequence of operations. It parses the customer's angry message and realizes there are two distinct problems: a billing dispute and a shipping error. It chains the tasks required to solve both.
So LangChain acts as the cognitive scaffolding, directing traffic. It realizes it needs data to solve these problems. Where does it go?
It initiates a two-pronged context retrieval approach. First, it uses Amazon Kendra, an intelligent enterprise search service, to search the company's unstructured FAQ index.
Okay, checking the rules.
Right, it checks the standard corporate policy regarding overcharges and shipping replacements. Simultaneously, it engages Amazon Bedrock, utilizing the Anthropic Claude model to process the generative logic of how to respond.
But the FAQ policy isn't enough to solve the customer's specific problem. The system needs to look at the customer's actual private bill.
Which triggers the enterprise execution phase. Governed by the clean core security protocols, the AI securely queries the SAP S/4HANA backend system.
Digging into the vault.
Exactly. It reaches deep into the enterprise core to pull real-time, highly specific customer transactional data. It finds the exact invoice in question, compares the quoted price for the steel beams to the billed price, verifies the overcharge mathematically, and then checks the logistics database for the status of the replacement tracking number.
And it is doing all of this data gathering, reasoning, and policy checking in milliseconds.
Yes, which leads to the final result. The AI synthesizes all of this information and generates a tailored instant resolution.
What does it say?
It responds to the customer. I apologize for the discrepancy on invoice 402. You were overcharged by $450. I have instantly issued a credit to your account. Regarding your replacement order, the tracking number was updated by the carrier an hour ago. Here is the correct link showing delivery by tomorrow at noon.
Man, what does that mean for the person sitting at their computer just trying to fix their business problem? From their perspective, they don't see AWS Lambda. They don't know what LangChain is. They have no concept of vector math or SAP S/4HANA.
Exactly. From the user's perspective, it just feels like magic. They experience an instant, perfectly contextualized resolution that fully understands their history and possesses the authority to actually fix the problem.
No hold music.
They didn't have to wait on hold. They didn't have to explain their problem to 3 different representatives. They didn't have to wait 3 days for an email reply.
That shifts the entire paradigm of customer service. Historically, customer service is viewed by corporate boards as a cost center. It is a necessary evil that you try to spend as little money on as possible.
Usually.
But an interaction like that turns customer service into a profound loyalty builder. If I know a supplier will fix my problem instantly with zero friction, I will never buy from their competitors. It becomes a massive competitive advantage.
You've hit the exact strategic value. And achieving that level of seamless, magical experience requires the incredibly complex architectural blueprint we've been deconstructing. The strict clean core, the intelligent orchestration layer, the RE grounding.
Right.
It takes a mountain of engineering to make it look effortless.
This is all genuinely mind-blowing, but I have to imagine if you were an enterprise leader listening to this and you want to build this incredible architecture for your own company, it can feel completely overwhelming.
Oh, I'm sure it's daunting.
You don't just flip a switch on a Monday morning and suddenly have a fully integrated generative AI ecosystem running your supply chain. How do you even begin plotting this course without risking millions of dollars on a failed implementation?
It is a massive undertaking, and many companies fail because they try to build the technology before they define the business problem.
Classic mistake.
Right. The source material concludes by addressing this exact challenge in a section called Mapping Your Organization's AI Horizon. They outline specific, structured tools that organizations use to navigate this transition safely.
Let's talk about those tools. What is the first step a company should take?
They recommend starting with the SAP Interactive Value Journey. The source describes this as a central repository of real-world use cases, curated into a format that resembles a playlist.
Playlist format. Why structure complex enterprise software like a music app?
Because the biggest initial hurdle for enterprise AI isn't the technology, it's the imagination gap among leadership.
The imagination gap.
If a board of directors doesn't fundamentally understand what AI can actually do for their specific mundane operational problems, they won't approve the budget.
That's true.
The value journey makes the abstract technology accessible. It spans cloud ERP, spend management, HR, and business networks. A decision maker can look at a playlist of how a company similar to theirs successfully implemented AI for automated bank statement processing and immediately grasp the tangible benefits.
It provides the proof of concept before you commit a single dollar to development.
Yeah.
It bridges that imagination gap.
Precisely. It helps them envision and materialize the benefits. Once leadership has the vision and the specific use cases in mind, they move to the second tool, the SAP Roadmap Explorer.
What does the Roadmap Explorer actually do? Is it just a timeline?
It's an interactive planning tool used to view, filter, and customize upcoming AI feature releases. The technology is moving so fast that SAP and AWS are constantly releasing new capabilities.
Hard to keep up with.
Very hard. The blueprint gives examples like natural language querying for specific databases or new duplicate account detection algorithms. Crucially, the Explorer maps these upcoming technical releases directly to your specific industry and process needs.
Take that analogy one step further for me. It's kind of like having a highly specialized travel agent for your digital transformation.
A travel agent, yeah, that fits.
You don't have to build the itinerary or the train schedule from scratch. You tell the Explorer your destination, say, optimizing a pharmaceutical supply chain, and it shows you exactly when the pre-built trains are leaving for each specific capability you need over the next 2 years.
That is the perfect way to look at it. What this highlights is a fundamental truth. Enterprise AI is not a one-size-fits-all out-of-the-box deployment.
It takes planning.
These mapping tools are absolutely critical because they allow companies to align this massive, intimidating technical blueprint with their specific, unique business intent long before they write a single line of custom code.
This has been an incredibly dense, fascinating journey through this blueprint. We've covered a massive amount of ground today.
We really have.
Let's synthesize what we've actually learned. I think the biggest takeaway for you listening right now is that enterprise generative AI isn't a parlor trick. It's not a standalone chatbot writing funny emails or drawing pictures.
It is a highly structured, deeply orchestrated, profoundly secure ecosystem. We've seen how disparate business intents from across a massive corporation are funneled safely through a clean core pattern to prevent data leaks and spaghetti code.
Right.
We've explored the complex, three-layer architecture SAP build providing the interface on top, the generative AI hub orchestrating the logic and security in the middle, and Amazon Bedrock providing the raw foundation models at the base.
And we dug deep into the mathematics of RAG retrieval augmented generation and how vector engines turn human language into thousand-dimensional coordinates to ensure the AI uses factual, grounded, private enterprise data instead of hallucinating.
By utilizing this structured architecture, massive multinational companies can safely and securely bridge human intent with technical execution on a scale we have never seen before.
Bringing it back to your daily life, whether you run a global supply chain or you are just trying to organize your own digital life and figure out which AI tools to use for your small business, understanding the mechanics underneath the hood is vital.
It really is.
Knowing the difference between a raw foundation model that might hallucinate and an orchestration layer that actually controls and grounds it gives you a massive strategic advantage in understanding how the modern digital world is being built.
It demystifies the technology. It allows you to look past the glossy marketing exterior and understand the engine that actually drives the value.
But I want to leave you with one final lingering thought. Let's go back to that concept of predictive supremacy we discussed in the very beginning.
Nice.
The idea that this blueprint eventually allows enterprises to use natural language queries and massive data synthesis to instantly forecast the future of markets, supply chains, and consumer behavior.
The ultimate strategic endgame for any corporation.
Right, so here's the provocative thought to ponder. If we reach a point where this architecture achieves true predictive supremacy, where the AI can parse global data, understand every variable across a 50-story corporate skyscraper, and see the future market trends better, faster, and more accurately than any human board of directors ever could. What actually happens to the traditional corporate structure?
That's the million-dollar question.
When the AI is the one looking around the corners and predicting the storms with mathematical certainty, who is really steering the ship, we started this deep dive by asking how you trust an AI to run a global supply chain without going off the rails. But maybe the real question we should be asking is, how long until we realize the AI is the only one who can actually read the map?
A fascinating and slightly terrifying question to leave on.
Thanks for joining us on this deep dive.